important subject because today if you see everywhere, even mechanical people they study, most of them they study this power electronics because of the electrical drivetrain design, and the most important component is electrical motor and the power converters. So that is what today this subject became a very important in many universities all over the world. So uh, this is what electrical vehicle design. Now we are designing a vehicle which will have a foldable, and we work on high power drives like traction motor, high power industrial motor drives, and wireless power. So we develop many products in the lab. It's not that we only do some kind of research, rather we bring all these things to the market and the motor for the hub motor for that vehicle. So many things we developed here in this lab and it goes to the market. This is a book which we will follow. This is a book just recently launched today. So I have not added another point I forget today. First thing is current energy revolution has the power electronics at its heart. Any kind of energy you take as a hydro energy or micro hydro turbines, and you don't require for big hydro turbine, but micro hydro turbines, and you have wind turbine, solar energy, and you have fuel cell, hydrogen, everything, all kind of energy and storage. You required the power electronics at its heart. So this time we are offering a course, not this time, next time we are offering a course which is electrical vehicle design and dynamics. So which is combined between electrical engineering and mechanical engineering. And you will be astonished that this time nearly 6 mechatronics students, they are only doing project in this power electronics based electric vehicle, magnetic gears, so many things we are designing. So that is why the energy now is a very important concept. This energy is now became the most important factor of converting from one form to another form. I'll give an example. Just 10 years back, if you want a DC, you have to bring a AC motor and drive a DC generator, you will get a DC. So you required a bulk machine, big machines. According to rating, the size of the machine also increases, and big machine bring together for converting from AC to DC. Similarly, from DC to AC also you required a big motor, and if you have a DC motor, then drive the AC motor or AC generator and you get a AC. But today, in our doorstep, very small chip can convert a AC to DC and DC to AC, like your charger, like your mobile charger. It's simple, and your hard drive required the 6 volt and 1 ampere current. Like that, there are. If you open the computer, you will find there is only one key which is entering, but output is multi-port, and that is called the switched mode power supplies, or SMPS, switched mode power supplies. Now the size of your computer is depend on this power supplies only. You see in a mobile, why this thin mobile, very small mobile, why, how it is come? It comes by only choosing the power supply is most important factor in designing. That's why you cannot, for example, you cannot have a unified design for everything. No, you need to have a systematic or customized design according to the requirement of the load. So that is why built in the industry, coming in the big ways, power electronics. But the power electronics, the Professor T. L. Lipo, he is a professor in Wisconsin, and he has given very few thought in IEEE transaction magazines. that today very few engineers have a thorough understanding of power electronics, because you required many many concept to come to power electronics, and it is so vast that very few people are available today. Every industry, like one of my friend is working in South Shakti, have required broad background and innovative thinking in this power electronics. So what is the power electronics? I think all of you studied the electronics, semiconductor devices, everything you have studied. But you have not studied the power semiconductor device, and we will discuss that one. Power electronics involve the study of electronic circuit to intend the control of flow of electrical energy, and this circuit handles energy flow at the level much higher than the individual deficient use of the power electronic device. So for example, we will take one example, IRF 42247. Okay, this is a MOSFET, metal oxide 227. Okay, so this MOSFET rating is, voltage rating is 200 volt, and current rating is 50 ampere, and power rating, you see this power rating is 3 watt. 3 watt means it will dissipate this much of power when it handles 1000 of watt of power. So the rating, power electronics rating is 10,000 watt or 10 kilowatt power. You can see that the device is very small, but they handle the power at the rate of 10 kilowatt and the power handling capacity. So what is this 3 watt? 3 watt, similarly this device also having, you have this power dissipation is 3 watt, and without heat sink. If you will add the heat sink means which transfer, because 10,000 10 kilowatt. That is why this is became very popular today. So why power electronics? There are many electronic circuit and analogous circuit we can use for transforming power from one form to another. Also you have a transformer, also you can transform. So what is the speciality about the power electronics here? So you see, I want to supply this, I want to know that this is a voltage, and we have a voltage divider first. Okay, and then we have a Zener regulator, because you have one voltage level and you want to operate the load at other voltage level. So you have so many different kind of this RL load you have to supply. So to supply this one, I have used a potential divider by which we get a voltage which is lower than that input voltage. Similarly, we can have a Zener regulator. You can stabilize the voltage at the output, and all of you must have studied in your electronic circuit design. Okay, so this is another circuit. Another one is a transistor regulator. We use a regulator transistor, and from output you can understand what is the lower voltage, because you know that this input voltage will be always higher than the output voltage. And then we have a power electronic switch here. Power electronic switch, when we use, what is the benefit? So that four, if you analyze this four circuit, you see the voltage divider will give you the efficiency of 50%, and your Zener diode will give you the efficiency of around 45%. And this, if you see, this gives your transistor gives BJT, or bipolar junction transistor, gives 50% efficiency, whereas this power electronic switch gives nearly 100% efficiency. Now even if we are able to develop up to 98% efficiency these power converters, and especially now the silicon carbide or carbide devices. So the power electronics is required. There are a lot of applications. In the residential, you start from your controlling your fan, in our fan, you will see that previously there was a big board used to connect, and I remember we used to turn this around. But now your fan controller is very small, and that is what a track they used, and they control very easily the speed of the fan. So if you see from your house, starting from a fan regulator to your refrigerator, space heating, air conditioning, cooking, lighting, and your induction cooker, everything, microwave, everything is the power electronics device which controls the high frequency applications. And commercial heating, ventilators, central refrigeration, lighting, computer, lighting system. If you go to any big the hotel, everywhere the lighting is the most like there is in Dubai something bridge or something like that. They design the whole lighting system. This is based on the power electronic switch. Uninterruptible power supplies, elevators in your house, in your colony, in the airport, everywhere. The power electronics is main component in that one. Even lift, everything. Like industrial pump, compressor, blowers, machine tool, furnace, induction heating, lighting, everything is in high power drives. And transportation, if you go nowadays, if you go to Indian Railway, so if you see in the when you are boarding the train, you see in the engine which is written WP7. You must understand that that is a AC traction motor. There are AC traction motor, DC traction motor. Previously, which is in India government plan in 1997. Now, then they have established Chittaranjan for students also to Chittaranjan to show this AC locomotive, and DC locomotive built in most of the northern part of India. We built in the DLW Banaras. Diesel locomotive works in Banaras we built, and then these big motors, you go to tram control in the electrical tram to metros, all kind of things. You will find that electrical the power electronics is the core of the heart. The power electronics is in the very the core of that complete engine. So WP7, when you look, you must understand that this is a AC coach. Okay, in the when you see in the railway traction, 25 kV transmission line, and the northern electricity is connected through that DC link. Okay, that is what the DC link transmission system, and it is erected by ABB Switzerland. The initial design, it was designed in Switzerland, and then it was installed in India in 1996 first. And static var compensators, SVC, but you don't know that when an electricity come, like water comes from in the Ganga river, you see there are a lot of industries, they put their garbage into the Ganga river. So what the Ganga river became polluted. Similarly, when the electrical energy flows from the generator to the load, many devices such as the computer, Xerox machine, your chargers, everything they required pulsating current. And pulsating current, when they draw the pulsating current, the complete current is the polluted because they require pulsating, they don't draw the sinusoidal current. So because of this, they produce a harmonic. Harmonic is called the pollution in the load. Like pollution, that is called the harmonic. Harmonic means pollution. So indeed, then draft fan, feeder pump, so all many things, and energy sources for the supplement wind, photovoltaic fuel cell, everything. Biggest power electronic distributed system, and one can ever see. So if you go, the complete shipboard power supplies in Auckland, one of the power supply I visited, that at least there are 6 generators and there are 6 generator and around 6000 HP drive, around 4.5 megawatt the throttle power supplies. And throttles are designed like an induction motor. The shaft is peeled around, then you put a fins, and those fins are that they should be stabilized because that there are lot of vibration due to the different kind of current flows. So first of the project we also designed here multi-phase machine drive, and people now use multi-phase more than three phase, so that if one phase is failed, then other phase can be utilized. Another is charging infrastructure. Now India government is looking that anybody want to design a charger for them. It is a very big gift, and this is also renewable energy Agartala, and we're planning to develop that type of devices. So there are a lot of application today. Energy storage also one of the biggest application where you can store the energy, and how to store it, you must have power electronics as the most important factor in that one. Then there are different feed pumping system also, and draft fan and boilers also we use this type of power electronics converter. So if you see here,
in power electronic systems that make an important contribution to reducing global energy consumption and emissions. E-mobility is one of the fastest growing markets of the future. Semicron's power electronics are used in fast charging stations and in vehicles at the interface between the motor and the battery. Power electronics also help to control the output power of drives for long-distance and urban electric trains and supply energy to auxiliary units such as lighting, ventilation and air conditioning systems. The largest application area for power electronics can be found in industrial and commercial applications such as motors and electric drives for robots, pumps, fans, cranes and machines. Power supplies are required for systems that need to be available at all times, such as in data processing centers. Silicon carbide modules are increasingly used in medium and large systems. Renewable energies are our second most important market. For the solar market, in addition to standard modules, we also offer customer-specific solutions. Our customers in the wind market can depend on intelligent power modules in pre-tested units consisting of the power circuit, driver, heatsink and sensors.
so based on this one, the all over the world they took initiation in the power electronics development. The major initiative are the European Center for Power Electronics in 2003, and then power electron centers in the USA started in 2004, and especially I also worked in this Tennessee Valley Authority in Tennessee. They supplies the complete power electronics module development in the different universities all over the USA, especially the universities connected to Tennessee, like Mississippi, North Carolina, like Denver, Houston, and 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 also Mississippi State. They all are supplied. They give the project for the development of power electronics. And India government also started in 2008 the National Mission for Power Electronics Technology. And this time also, last two time, there are a lot of nodal centers they have created. And we are happy that IIT Patna is one of the nodal center by which we are doing development and the drives and the high power industrial drives application. So there are major journals also available in, you see that in IEEE, the topmost journals are for the power electronics like industrial electronics, smart grid, industrial information packaging, industry application, power electronics, energy conversion, power delivery. Now there are also nearly 20 additional journals on power electronics came in, especially in IEEE mentioned here. So what a power electronics engineer need to understand? First, power electronics engineer need to understand one is a dynamic modeling circuit, control system and signal system. It's very essential for understanding the power electronic system and for controlling microprocessor, microcontroller, digital signal processor as well as and the FPGA also boards we use here, and then designing and packaging and thermal design, which is also very important how to design the power circuit, because that is why if you see a in your laptop there is a fan. So that why that fan is given accordingly, whatever the wind speed or the exhaust fan you required, that exhaust fan is there just to remove the heat from the processor. And then power system, electrical machines and all electrical circuit, everything you required in this power electronic course. And communication is for controlling and for pulse width modulation, the different kind of modulation technique which is used in the communication system. And we use the same thing, but nowadays because of the IoT, power electronics and artificial intelligence comes into picture, so this completely, this all together now became a very popular thing here. And IoT, now this microelectronics, everything come packaging, that is called the power electronics 2.0 is coming up nowadays, where you have a communication, then data acquisition, microelectronics design, VLSI, everything you need to understand. But then we can become a complete power electronics engineer. So that is why a vast knowledge of electrical, computer, mechanical, thermal modeling, everything is required to design a proper power electronic circuit. And we have a source. So the load and source and the middle is your power electronics converter. And this power electronics converter is enabled to supply required voltage, required current. Whether your source is AC, you require a DC load, so you need to convert from AC to DC. If source is DC and you required in the AC load, so source and this both you must connect. A DC must be transformed. How to transform? That will do by this power electronics. You have a DC and your load is AC, you can convert from DC to AC. Or you have a variable frequency AC and you require variable frequency AC, that also frequency conversion also takes place. Power conversion or mode of conversion, frequency conversion, phase conversion, any kind of things you require, this power electronic circuit can supply you. So that is what the controller must be designed. So when we design, that's what I always say to our students, that power electronics people, they know better control than a control engineer, because in the practical system, a non-linear system, the power electronic switching system, when you are able to control simply a linearized model by using RH criteria or root locus criteria or Bode plot or Nyquist plot, it is very easier for a power electronic engineer to understand whether stability, whether find out the parameters, anything you can do very easily, because you are very conversant with the nonlinear system. This power electronic system as well as non-linear loads like a induction motor load, very highly coupled machine, induction machine. So like that, this power conversion, for example, you see, if I will ask you, I want to convert a 6 volt to 48 volt and 10 ampere current to 1.25 ampere current. It is both are DC. So if I will ask, I think we do not know how to do this. But this was the first design by NASA. Nobody understood, but they have designed. And this is called the, like in our AC system, you can say that, sir, we can use a transformer from a high voltage to low voltage, we can make. And when you have this current according to load, you will have accordingly your load current, you will get a input current. So transformer in the case of AC. If I will ask in DC, it is very confusing that how it can be done. But this is a simple circuit, a power electronic circuit. We have a switch, okay, here, and we have a input inductor here, and we have a capacitor, a filter capacitor, and a load. And this, although it was developed long back by NASA, and R is, this one is designed according to our 6 volt and 48 volt design. Although this was designed, but the analysis was not available till 1984. So this particular thing is in 1970s. It was designed for the space station, but this justified the design in the 1990s. Now, good control for good design techniques have not been fully developed. So now, due to the electric vehicle also we require this type of power supply. Lot of papers comes on this matter. So power electronics, we have different kind of conversion system. That is why another name of the power electronics is power converters. Power converters means if you have a AC signal here and you want a DC, you need a rectification. I think all of you knows this because in your basic lab you must have done the AC/DC, that rectifier circuit. And if you have a DC, you can design another DC, because one fixed DC to variable DC you can get by using DC choppers. And from DC to AC is the inverter. In your house somebody will ask you, oh, you have inverter? People is very popular, inverter they ask, but they don't know that it is a simple UPS system. UPS system generally in villages they known as inverter. Inverter means converting from DC to AC, but the UPS system you have a charger, then you have an inverter, but they call that, hey, you have an inverter, like that. Now inverter also we will study detail, because inverter is also very important aspect. And sometime we have AC drive. From a fixed AC you require a variable AC, and this is called the cycloconverter or matrix converter by using AC. And when the rectification by using the AC/DC. And inversion is inverter is your inverting circuit by using, and the conversion DC to DC, okay, I will take other color maybe. This is your DC to DC conversion is by using chopper. So this 4 way of converting is the complete power electronics course. We will complete this. Then few applications, 1 or 2 application, and this time I will take application as an electric vehicle, because we worked a lot on the electric vehicle front, and that is what I will take example this year as a charging stations, optimal design of high current multi-port charging station, because we have designed for the e-rickshaw that 5 charging station of 750 watt chargers. So we have designed. So I will take that example in the end of this course. Okay. So then rectification, you know, it is from you have a AC signal and you convert to DC. This is called the rectification. And then when we have a DC signal, constant DC signal, you convert to AC signal or alternating signal is called the inversion or AC to DC converter. Okay, then if we will go to next is a cycloconverter. You have a AC and you convert to the AC. Here I have made wrong. Okay, no, no, this one is a cycloconverter. Your AC to DC, DC to AC, you can see. But this is not this one, this is AC. AC to AC. This is a cycloconverter drive, and first cycloconverter was designed by Professor A.K. Chattopadhyay in IIT Kharagpur in 1979. He developed this first matrix converter, and he is a IEEE fellow, the first IEEE fellow, and he is a man on AC drives. Okay, and first matrix converter also developed in India only, and that is also AC drive control in IISc Bangalore. And last year also we developed here at IIT Patna as a matrix converter drives. So then this is the matrix converter which one of my friend is Maherji from Ethiopia. He was doing PhD in IIT Kanpur. He designed this matrix converter. You can see that this is like a matrix, 3 by 3 matrix, 3 by 5 matrix, 5 by 5 matrix you can design. This converter he designed for synchronous motor drive, and this project he started. It was very tough that time, and he could able to run it, and but unfortunately he could not able to get PhD because of some other reason. But he is still working in John Deere in North Dakota in USA as a application engineer, power electronics application engineer in that place. So then we have a DC to DC converter. This is a DC to DC converter. You can see that fixed DC to variable DC converters, and these are the few things. And this course I will give a few. I will try to give more simulation based assignment, and because this time this course we will discuss more in the detail, and then assignment also, and I will take also Viva. Okay, because there is no proper way of understanding, but I will take any time. I will start after the mid-sem, like 4 5 people. I'll take whole semester Viva. Okay, so I will continue this, and we will plan some quiz or assignment, something if possible. We will do that because it is pandemic time. I don't know how we can do it, so we will plan like that. Okay. So the books we will study, the first book, because I refer this book, my book, because I have given around 400 problems in that book, 400 problem and solutions for that one. So that is why this book I will follow.